Thank you so much. And thanks for coming along. It's very nice to see all of you. As he said, my name is Hrafn Eiriksson, and I, like a lot of people around this conference, it seems, am quite interested in async I/O, and that's what I'm going to be talking about today. You've maybe been to some of the other async I/O talks this morning. In my mind, they were a little bit kind of theoretical, but I'm here to try to represent the more practical side of things. So yeah, just trying to use this thing and make it work. So the first thing that I want to do today is to, get a feeling of how many people in the audience have toyed around with async I/O in Python. Shows of hands. We definitely are in a Python conference, that's for sure. The more interesting question in my mind, however, is the following. How many of you have created actual mission-critical systems in Python using async I/O and kind of, deployed them to production? That's still quite a lot, but yeah, still way less than the number of people that have toyed around with async I/O. And this seems to be the case everywhere where I ask this question. Most Pythonistas have played around with the thing, but it hasn't really made its way into their production systems for one reason or another. And this is despite the numerous blog posts and articles and all of this stuff that details how massively async I/O libraries outperform their kind of synchronous counterparts, but also like their asynchronous alternatives. So why aren't everyone using async I/O in production when it's so obviously all rainbows and unicorns? And there are definitely a number of reasons for this. I'm just quickly going to go through some of my personal favorites. First of all, asynchronous programming is very different. It requires a very different mental model of how to do programming, and it takes some time to adjust to. Secondly, the async I/O feature in Python is relatively new to the language. And by that, I mean async I/O. I don't mean like Tornado and all of that kind of stuff, because that dates back to 2002. And programmers are a little bit kind of reluctant to new shiny things when it comes to their production systems. It's kind of interesting because at the same time, we are very much drawn to new shiny things. So it's a very thin line. So third, to convert an already existing Python application to async I/O is non-trivial. It takes effort. Fourth, due to the lack of native support in the language in the past to do asynchronous programming, the community has come up with solutions to this. They've come up with libraries like Eventlet, Tornado, Twisted, all of the stuff. And many of these libraries are widely used, and they just work, and people kind of just stick with them. So last, probably most importantly, asynchronous programming is not always the solution to your problems. Now, it so happens that I do have some experience with migrating actual in-production Python codebases to use async I/O. And even though async I/O is by no means perfect, my experience thus far has been quite positive. And that's kind of why I'm here today, a little bit to spread the word. So my talk today is split roughly into 3 parts. In the first part, I'm going to be discussing what led me to commit a lot of time and effort, into migrating software that was already working in production to use async I/O. Then I'm going to talk about some of the roadblocks that I hit during this time, and some of the caveats that you might want to be aware of if you want to do the same thing. Last, I want to talk about some of the benefits of this work, and try to back this up with some empirical data. I should probably also mention what this talk is not about, just so we're on the same page. It's actually not a lot of things, but mainly it's not an introduction into async I/O and how it works. So yeah, you're going to have to look that up somewhere else. But even though you have absolutely no knowledge of it at all, don't worry. I'm hoping this talk might at least kind of trigger you to explore the subject further. Interesting. So why would you want to bother with async I/O? Sorry, I'm just not going to touch this thing. So your software already works, right? to understand where I'm coming from personally, we're gonna need to explore my background a little bit, just a teeny tiny little bit. So in my past, I worked for a company that was obsessed with using Node.js for everything. Admittedly, I was kind of one of the people in charge, so I cannot really free myself from that. But despite Node.js's and JavaScript's multiple pain points, these technologies still taught me how useful asynchronous programming can be and how efficient it can be, especially when your applications are just mostly I/O bound. By the end of my tenure at this company, I had gotten used to writing everything, even what would be very simple sequential scripts in Python, in an asynchronous fashion. So when I joined my current employer, a company called Smarkets, I had kind of to get used to a new reality. Smarkets is a company that relies heavily on a microservices-based architecture, and most of these services are coincidentally written in Python. So initially, when I started looking into how these microservices were structured and how they were coded, all I could see was just plain old blocking Python code. To be honest, I wasn't too impressed, especially coming from my awesome asynchronous background. So at this point in time, I started thinking, like, how are they scaling these things? Because some of these microservices were taking on some serious traffic. So after a bit of research, I noticed that most of these services were scaled out in a fairly classical Pythonic way. Each service was running in multiple instances, application instances, and each instance was a unicorn server that had, multiple workers. So scaling out was a matter of adding new application instances or adding new workers, or both. So because our microservices are very I/O bound, it was kind of apparent to me that all of these workers on the end were just going to be stuck waiting on I/O the whole time. I was just thinking, like, what a waste. And after thinking about this for a while, I noticed that a big part of the services depended on a package that was somewhere deep down doing this thing here. Probably some of you know this thing. David actually touched upon this in the keynote this morning. But obviously, my Node.js acclimated mind did not realize immediately what this did. But after some research, I figured out that this actually patches the standard library. So your previously kind of blocking code will magically be doing asynchronous things behind the scenes. Cool. So before async IO came along, this was apparently one of the kind of standard ways of achieving concurrency in Python. In my mind, this is problematic in multiple ways, mostly because this is kind of hidden away from the developer. It's quite magical, and it's hard to reason about as well. Also, like many developers on my team and in the company, were not making use of eventlet's multiple concurrency primitives because they didn't even know this was happening somewhere in their kind of software. So the moral of the story is that async IO itself and the kind of async/await keywords make this way more explicit. And someone told me that explicit is better than implicit. I should probably note that I have absolutely nothing against Eventlet in general, quite the opposite. I find it fascinating that they were able to create something that works so well that I didn't notice it for, months, that it was kind of like doing asynchronous stuff behind the scenes. But now that we do have async IO, I think we should kind of start using that. So yeah, to summarize a little bit, there are multiple ways in which we can achieve concurrency in Python. But in my mind, async IO is the obvious way to go because it's explicit and it's a part of the language. It's also supposedly quite performant, but we will get back to that later on. So assuming that async IO is indeed the future and that we want to kind of, make our new projects use it or migrate our existing projects to use it, what issues are we going to run into and how simple is it? I've already mentioned it's actually not super simple, but it's definitely getting better. It's getting way simpler than it was. Not that long ago, when I was taking a look at async IO in Python for the first time, I noticed that people were relying quite heavily on monkey patching, again, their dependencies, just to make them work with their async IO code. For anyone that's serious about their code base and like serious about the reliability of their system, that's probably not a great idea. But since then, for the kind of past, a couple of months, maybe up to a year, it seems like the async IO ecosystem in Python has grown and matured rapidly. We now have loads of mature web frameworks, loads of mature kind of database drivers, and just a lot of libraries for a lot of stuff. And yeah, it's getting quite good. So I kind of feel now like it's getting to the point where library authors should no longer be ignoring async IO and instead kind of defaulting to it. Now, because I'm a very practical person, as I spoke about earlier, I think the best way to describe how you should go about migrating a Python project to async IO is simply to describe the process that I went through recently when I moved one of our kind of in-production microservices to use async IO. Having done this before, I knew that the first thing I'd need to do was to kind of map out the dependencies of the service and research if there would exist async IO compatible versions of the dependencies. And also, since this was a microservice that exposed like a RESTful API, obviously I had to figure out which kind of web framework to use, always a classical problem. And when researching these kind of async IO web frameworks that we have now, I was pleasantly surprised to see the kind of wide variety of web frameworks that we have access to. This slide just shows a few examples of those. And all of these are kind of specifically targeted towards async IO. Some of them aim to be Flask-like, some of them aim to be fast, some of them aim to have good WebSocket support, and some of them aim to be compatible not only with Flask's public API, but also its private API, in such a way that you're basically supposed to be able to do a find and replace of Flask to Quart, and you just sprinkle a few kind of async await keywords around, and it just should work. I haven't tried it out, but I don't know. A colleague of mine, Phil, actually wrote this framework, so yeah, it probably works. He's a good guy. This can be, obviously, this can be very useful if you are migrating a large kind of Flask application to async IO and you just want to get up to speed quickly. Now, I didn't care that much about API compatibility with Flask, so I decided to go with another web framework, which is called aiohttp, simply because it's known to be mature, it's battle-tested, and I don't want to take my chances with new shiny stuff like Quart. But even though the aiohttp API is a little bit different from the Flask API we all know and love, migrating to it was super simple. And in fact, I kind of felt a little bit kind of relieved to be rid of the global request object that I've always found a little bit odd. Is that just me? Anyway, the same can be said about the migration from psycopg2, which is the old database driver that we used for Postgres, to asyncpg, which is the new de facto awesome Postgres database driver for async IO, except for the desperate lack of named parameters, if the developers are in the room. I was a little bit worried that migrating Sentry, the error tracking software that we use, would be problematic. And after searching the internet for a little bit, I found some packets on GitHub that was supposed to be, an integration between Sentry and aiohttp. Couldn't really make it work. So I figured it's just going to be simpler for me to do this myself. So I had already worked with middlewares in aiohttp, and I knew I could easily implement something like this as middleware. And literally 5 minutes later, this is what I have. Very typical middleware, just runs the request handler, and if the request handler raises an uncaught exception, my Sentry middleware will capture the exception, fire it off to Sentry, and then just raise again. Super simple. So obviously, this also makes use of the fact that the Python Sentry client library also has support for aiohttp as a transport. So far, so good. Unfortunately, my migration was not completely without issues. One of the features of my microservice prior to my migration was that its API was built and defined in Swagger, And it had some kind of fancy Swagger UI thing on top of it, so you could kind of interact with the API. It's really cool. Anyway, this support came through a library which is called Connection. Probably some of you know it. And after researching Connection for a little bit, it looked like it would support using aiohttp as a backend, but then I kind of tried it out and it didn't really work, and the documentation was kind of non-existent. So what I probably should have done at this point in time was just to fix the Connection library and the documentation, but it's on my to-do list, no worries. Yeah, instead I just dropped the Swagger thing. So up until this point, I've been talking about async IO like it's the perfect piece of software, and it's not. Yeah, it's absolutely not. There are quite a few things you might want to be aware of before starting to use async IO, and I'm just going to mention some of the issues that I've personally experienced. Yuri spoke about more issues earlier, and yeah. And I think someone is talking even more about issues tomorrow in another talk. So plenty of that. First, while async IO is conceptually simple in Python, there is a steep learning curve to understand the whole beast. We're talking about event loops, event loop policies, awaitables, coroutines, generators, futures, tasks, executors, transports, protocols, etc., etc., etc. So if you're migrating a large, important code base to use async IO, you'd ideally want to understand most of these and kind of how they interplay. So yeah, this takes time. Another issue that many developers that try out async IO mention is as soon as you start developing, like migrating your Python code base to use async IO, your code base is going to be littered with async and await everywhere. To me, like, yeah, I kind of experienced this, but to me, this is not a huge deal. This is just the cost of explicitness, and I'm going to welcome that. An issue that definitely did hit me personally was the fact that sometimes the async IO stack would just, make my debugging life a little bit too difficult by kind of swallowing my exceptions, and I had like no idea what was going on. But this is definitely getting better every day, and this is something that Yuri, one of the Python core committers around async IO, spoke about earlier as well. So I'm very happy to hear that. Now, accidentally running synchronous code that waits for I/O inside of your asynchronous functions, yet another source of issues. Here, what I can tell you is it's very simple to monitor the event loop. It's basically just about figuring out which tasks on the event loop take longer than X milliseconds. And if some tasks are doing that, this might be a sign that it's actually doing some I/O or some kind of blocking I/O inside of the async functions. So yeah, as I mentioned, this is just some of the examples. So to summarize, if you plan on migrating a large project to async IO, or create a project from scratch, the most important thing I can tell you is just do the research first, map out your dependencies, see if there exist async IO compatible versions of them, and if they exist, actually make sure that they work and check them out. That's very useful. Watch out for some of the gotchas, and yeah, profit. So you've migrated all of your projects to async IO. Was it worth it? Are you any better off? Let's see how it went for me. I'm going to start out by taking a look at a kind of before-after evaluation of the microservice that I spoke about earlier. I've already mentioned the initial version of it had, Flask to declare an API. It had psycopg2 to communicate with the Postgres database. A lot of other stuff that matters less. Also utilized eventlet to make everything asynchronous behind the scenes. So in theory, it should have been quite efficient. We've also gone through how the after version of this microservice looked like. aiohttp as a web framework, asyncpg as a Postgres database driver. And to run the event loop itself, we used the Python implementation of the UV loop, which is apparently very fast. And this is kind of our experimental setup, quite standard. We used the work project, or WRK, to perform HTTP benchmarking of both versions of the service. We ran each configuration of the benchmark for 30 seconds, 10 times, using a variable number of connections. and noted the median, 25th percentile, and 75th percentile in terms of throughput, requests per second, for all of the 10 runs. We also had some delay between the runs just to kind of allow the server and client to settle. And on this slide, you can see this throughput comparison of the microservice running in quite a basic configuration with only one Unicorn worker and just on my machine, so just in development. We then use this work thing, the benchmarking tool, to test the throughput of both versions on a very simple just ping route that doesn't really do anything interesting. It kind of just returns the string pong. And we use this quite a lot in our microservices just to do health checking, like, are you alive? And as you can see, the results here are quite conclusive. Like the async IO version of the microservice, that is the yellow line, is able to handle on average 1,400 requests per second, while the event-led version is able to handle somewhere around 650. So in this case, the performance increase is somewhere around twofold. Here we can see another benchmark that we did, which is on a route that actually does things. It does, some interesting database accesses, and then kind of returns the results of the database access and some transformations. And in this experiment, it seems like before the event-led version is able to handle somewhere around 200 to 300 requests per second, while the async IO version, the yellow line again, seems to be able to handle somewhere around 800 to 1,000. Now, the most interesting one is probably this one. This is an actual benchmark on the microservice, both of them in production, both before and after the migration. And in this particular experiment, the number of Unicorn workers were just set to 3, and we only ran the benchmarks on one application instance. Usually we have more application instances in production, but testing all of them in conjunction is kind of besides the point here, because they are supposed to be able to scale linearly if the load balancer that you're using is okay. So as you can see here, the before version, the event-led version of the microservice performs okay. Like we're handling 1,300 requests per second quite consistently. While the async IO version, confusingly the green line in this graph, is able to handle around 7,000 requests per second. And this is more than a 5-fold increase in throughput. So this kind of means that we can just get rid of 80% of the application instances that we have in production, which is quite nice because we save a lot of money. So just to conclude the whole thing, is async IO worth the effort? We finally have explicit native support in Python to do asynchronous programming. That is kind of slowly but surely becoming the de facto standard in the community, and kind of replacing other concurrency libraries. And as we just saw, the performance of async IO is quite good. It's very positive results, and these mirror what I have seen on the web. So all in all, yes, I think it's definitely worth it. Go check it out if you have not. Thank you.
We have time for questions. If anyone has questions, please line up here. Hello.
Hey.
Thanks for a great talk. I wanted to ask if you had a problem with synchronous, long synchronous computation in your project.
I have, yes. I was doing I was using some stuff in our code that was apparently doing some very interesting requests, like using the request libraries somewhere kind of deep down. I didn't really understand why it was doing it, but yes, I experienced this problem, and it's completely terrible. Very hard to figure out in this case.
I wanted to ask, how did you deal with it? Or, well, when it is requested, it's easy, or maybe how did you monitor it?
Well, this is basically an issue that, it didn't take a long time for me to figure out why this was, because I saw that some requests were just taking too long, and we were basically everything was being held up because of this one request that was doing like this thing. So it was pretty simple for me to do it. I basically just found the code and I just literally threw it out. It wasn't necessary, so I replaced it. So that was my solution. Like another solution would have been to actually start using the aiohttp client instead of the request library. Then everything probably like it would have been able to make this work. Yeah.
Thanks. Great talk. Like, I might need like just a yes or no piece of advice. So what do you think about like running async IO and then running like 1,000 processes and waiting in a queue in the main thread to just pick them up?
Wait, so running 1,000 processes, each with like an async event loop, or?
Yeah, like everything's there. Like we are waiting for the tasks.
Yeah.
And like they're in the meantime, you're just waiting in the loop on the queue, and they're just the processes are writing inside. Does that make sense?
I'm not sure I understand, but
it's like using processes for the
using actual like operating system processes.
Yeah,
oh yeah,
like
I see.
Instead of like sending a request to a website, like running something in a
I think there's probably a lot of overhead in that, to be honest. Like a lot of overhead compared to what async IO gives us, which is very lightweight, kind of, just like some kind of task queue. It's running the queue. If you have to maintain all of these processes, and the operating system has to switch between them correctly. So I think there would probably be a lot of overhead in there.
Well, not if you run a Lambda in each and every one of the processes.
Yeah, we can discuss it more.
You've mentioned that async IO has a lot of. This works.
I can hear you.
Okay. Okay. So you've mentioned that like async IO has a lot of rough edges and a lot of complexity, like transports, awaitable stuff like. Do you actually use it? Like.
No, I don't. But like I feel like I need to. I have never done anything with transports or protocols, but given that I'm writing an actual, in production, very important microservice, I feel like I need to be on top of what this stuff is doing.
So you need to like re-implement SSL in your own code?
No, I'm not saying that. Absolutely not. I'm just saying I should probably know what these kind of basic building blocks that are behind async IO. I should know what they do, but no, I haven't used them. And Yuri actually talked about this earlier. Like, I'm not supposed to be able, I'm not supposed to need to know what these things are. So maybe I should just take his word. Maybe, but.
For me. But no, I was just curious if you actually go that deep in your.
I have not, no.
Okay.
But I still feel like I need to know it.
Okay, thanks.
Previously you talked about Swagger and that you no longer had Swagger support.
Well, yeah. So basically, the API is no longer defined in Swagger, and we don't have the Swagger UI for this particular microservice, which is.
So have you tried aiohttp Swagger?
I have not.
Okay.
So that exists.
Yes.
Oh, that's very good to know. That's very good to know. Thank you. Learning a lot today.
You mentioned about using async-TG for database layer access. What about using a more sophisticated things like ORMs, like ORM-likes?
So how should I put it? Like the code that I'm working with, the company that I'm working for, it doesn't use ORMs a lot, and definitely the projects that I have been using, they don't. So if you are, yes, you probably, this is one of the research things that you would need to do. If you want to migrate a project that's using an ORM, you're gonna need to figure out if there is some support for ORMs somewhere else. I don't know the answer. Like we don't really use ORMs. We just use, like SQL queries directly. So yeah, research it.
Okay.
Some of the shortcomings of async IO should be problems with cancellation, timeouts, and back pressure.
Yeah.
Did you run into any of these problems?
Yeah, like I've probably run into some of these, but like these are not things that I'm dealing with a lot. These services that, like for example, this service, not complex. It doesn't have to deal with a lot of timeouts and stuff like that. No, I haven't really run into a lot of these. No.
Thanks.
No worries.
Let's give our speaker one more round of applause.
Thanks.